So, we've done the expanding. Next thing, differentiate it. Jack, can you nominate someone to differentiate that, please? You do, okay. Nominate yourself. Far away.
Minus 3x squared.
From that bit there, yep.
And 18x.
From that bit there.
And minus 37.
From that bit there. That's the differentiating, okay? Oh, you can't see that on the board for some reason. There we go, okay? Right, so what was the step after differentiating last time? Factorising, okay. How can we factorise that?
Minus 3.
Take out minus 3, okay? So that's going to give us that. X minus 3 all squared. Okay.
Are we expecting, like I say, this becomes some question, would we be expecting to actually replicate it, so it would be 3 minus x?
Well, so, yeah, this thing here, okay, Jack's saying at the top we had a 3 minus x, here we got an x minus 3. What could we do about that?
The outside bracket should be positive.
That's okay at the moment. Everything we've done here, following through there is okay, because if we multiply that out, we will get an x squared, and then times that by minus 3, we'll get the minus 3x squared. That bit's right. How would you feel if I said this? Why does that make sense?
Because minus 3x minus 2 squared. Oh, it's the difference. No, it doesn't make sense.
It does make sense because
No,
the
it
negatives
does.
will cancel each
Yeah.
other out in the bracket.
Because if it was a cube, then that would become a plus 3 at the start, but because it's only squared, it doesn't affect anything.
Okay, if you think about this, okay, x minus 3 is exactly the same as 3 minus x with a minus sign in front of it. Do you agree that that is the same as that?
Yeah.
That's minus 3 and minus minus plus x. So they're the same as each other. And if things are the same but different signs, so if I did this a minute, because they are now not the same, one is like a plus version, one is like the minus version. What happens when you square them? Well, what happens if you square 7 and square minus 7?
Same answer.
Yeah. So when I square those, they will be the same as each other again. Okay, even if one is plus and one is a minus. So I can end up with this line down here. So on this one, I started off with 3 minus x cubed, and I differentiated it, and I've ended up with minus 3 minus x squared. Now I heard someone earlier on saying that they were spotting something. Okay? So if I put just those two together, those are the two results we've had so far. I put them together there like that. Okay? It may be that people would rather write this one down as minus x plus 3 cubed. I've just written things in different order. And over here you may prefer to write it down like that, because it's the same thing. Do you think you spotted something? Okay, before I ask you what it is, if I write this down,
I've got a thing. What? I've got a thing.
if I differentiate that, Beth, would you be confident you could come up with the answer? Okay. Is there, no, I don't want to hear it yet. Is there anybody else? I've got one person there who reckons they know what the answer is. 2 people, 3 people, 4 people. Lucy, which one of those people should we nominate to hear their answer? Hands up those who think they've got an idea what's going on. Okay, who do you want to hear from? Beth, you got it first. Okay, what do you reckon? Do those people who put their hand up earlier think that's right? Okay, right, let's try another one. Let's try 2x plus 3 to the power of 4. Right, is there anybody else who didn't put their hand up a minute ago? Maybe spotted what's going on. Where could that 24 have come from?
64.
That times that. Now, did it work up here, for instance? That's 6. Okay. So this one? 8. Okay, there is an 8, yeah. That 4 times that 2 is an 8. Then what? Open bracket. That's correct.
Yeah.
Right. So what have you done in words? What's the rule? Sorry? So, yeah. So can we go as far as... I'll try and leave some of those up on the board a minute. Juggle my paper around. If I leave those there. If we started out with ax plus b to the power of n and we differentiated it. Go on.
Would it be an open brackets ax plus b to the n?
The answer is yes, it will. Okay. So your first red box rule with me post AS exams is for differentiating a bracket with a power on it. The power and how many x's come out the front. The bracket stays the same and you reduce the power by 1. So, okay. If I write that down in words, what we have done is we times the coefficient of x by the power, and that's what goes at the front. Then we keep the bracket as it is, and then we reduce the power by 1. Okay, so that's what we do in words. Jack.
Does this only work when you have like 2 things going on in the bracket? Does one of them have to be algebraic?
For what we'll see at the moment, yes, we'll gradually extend it and you'll see as we go through.
Can you
Okay.
keep doing it? So once you've got the, let's say, I don't know, pick one of them, minus 3 lots of x minus 3 squared,
Mhm.
can you then differentiate the other half of the bracket or just keep working?
If you differentiate it again, you get the second derivative. You get d2y by
Yeah.
dx squared. You cancel the
But
cube.
does it still work?
Do we need to do
Yes.
Is that going to come later?
Yeah, lots of things are going to come up later, okay? Let's get some practice of this and then we'll extend, okay? So, some examples. Here we go. We're going to ask you, first of all, to find dy dx. We're going to do a bit more properly with the notation now. Find dy dx, first of all, if y equals 1 over x minus 2. That obviously looks like what we've just been doing, doesn't it? It doesn't look quite like what we've been doing. So we need to make it fit the rule. So there's the rule at the top. How can I rewrite this? So it's a bracket and a power on it.
X minus 2 to the power of minus 1.
X minus 2 to the power of minus 1. That's correct, okay? The 1 over is a minus 1. So the first thing to do there with that one was to rewrite it so it fits the rule. Okay? Whether I can freeze that rule at the very top. It's not working on the video, but it's not working in class either. Never mind. Right, here we go. So, Lucy, could you use the rule on this then? Could you now tell me what we will get if I differentiate this? Minus 1. Yes. Okay, that's right. It's a minus 1 times by the 1, x is minus 1. Brackets there, knock 1 off the power. Okay? Right, it's gone out of focus, thank you. Because it's frozen in class. There we go. Okay? Take that off as well. Now, It's in the question. You're expected to write your answer more like it looked in the question. So how can I rewrite this so it looks more like that?
2 over x minus 2 in the bracket times minus
You're nearly there, if I heard that correctly. Go on.
Minus 1 over x minus 2.
Yes. Okay. The minus power means 1 over. The x minus 2 bracket then has a power of 2, and there is a minus. Okay? So yeah, that's right for that one. Right, let's call that one part A up there, and have another one here, part B. Because we are getting slightly more complicated as we go through. This one is 1 over the square root of 2x minus 5. Beth,
That'll be 2x minus 5 to
2x minus 5 to the power of minus a half. Yeah, that's right. The 1 over is the minus power. The square root is the power and a half. So you need to rewrite it like that first of all. Beth, can you nominate someone to do the differentiating, please?
Jeff. Minus 1 and then 2x minus 5 and minus 3
Okay, I'm actually going to put in here, you bring the power down and you times by that 2, just to show where it has come from. But yeah, that does cancel out to be the minus 1 you said. Okay, so minus 1, 2x minus 5 to the minus 3 over 2. How can I make that look more like the question?
minus 1 over the 2x minus 5 to the 3.
I think you said that. Is that what you said? Okay, that's right. But the question had a root sign in it. Go on.
would be cube root 2x minus
Square root cube.
Yeah, it's the 2 on the bottom is square root, and the 3 is
5.
cubed.
So it would be square root of cube.
Yes, okay. And the easiest way of probably writing that is to write it cubed, then put the square root over that bit, and then the top of the fraction is the minus 1. Okay? Right, I'm going to stop the video there and continue in another one.